Hey, welcome back. So we're going to continue to try to solve some problems with dimensional analysis, and these problems are even more difficult than what we had before. And so let's go ahead and get right to it. Okay, so problem 11. We have a house with an area of 195 meters squared. And what we want to do is get this into centimeters squared. Okay, so what I'm going to do first to sort of explain how to do this problem, or excuse me, centimeters squared. There we go. What I'm going to do first is sort of do the problem wrong to help me explain how to do the problem right. So what I'm about to do right now is wrong, but we will correct it. So the wrong way to do it, although this would be understand why someone would do that, but this is wrong, is you say, oh, okay, so we're going to convert meters to centimeters. And so you say, okay, so I know that conversion. And so I know that 1 centimeter is equal to 1 times 10 to the negative 2 meters. And so what you might be tempted to do is you put times 1 centimeter here over 1 times 10 to the negative 2 meters. And then you do the math, you take 195 times 1, divide by 1 times 10 to the negative 2. If you were to do that, it wouldn't be correct. And so here's the problem. The problem is we have meters squared here in the numerator, and we have meters in the denominator. And so 1 meter in the denominator only cancels out one of the 2 meters in the numerator. So we did not completely cancel out the meters. So if you were to find an answer at this point, you would have 1 meter left, and you would have centimeters there. So the answer would be in some compound unit, meters times centimeters. So that wouldn't be correct. So you can see that we're going to have to somehow do an adjustment so that we have meters squared to cancel out with meters squared in the problem. So how do we do that? So what you want to do is, let's go ahead and take 1 centimeter is equal to 1 times 10 to the negative 2 meters. So what you can do to get this into an appropriate conversion where everything is squared is you square both sides of this equation. And when you do that, you have to square the number and the units. So if you have 1 squared, you'll have 1. Cm squared is just cm squared, so you can write that. 1 times 10 to the negative 2 squared is 1 times 10 to the negative 4. And then meter squared is just meter squared. So at this point, this conversion should work. 1 cm squared is equal to 1 times 10 to the negative 4 meters squared. So let's go ahead and use that. So it's times 1 centimeter squared over 1 times 10 to the negative 4 meters squared. And so what you can see is meters squared cancels out this time. So that's a good sign. And we'll get an answer in centimeters squared. So it's going to be 195 divided by 1 exponent 4. And so I get a pretty large number, 195 with 4 zeros, 2, 3, 4. Okay, so let's convert this to correct significant figures. We have 3 significant figures in 195. Both of these numbers are exact numbers, and so they will have an infinite number of significant figures. So the answer should be rounded to just 3 significant figures. So you can write either 1,950,000, or better yet, get this into scientific notation, which is 1.95 times 10 to the 6 centimeters squared. Okay, let's move on. Okay, a kitchen has a volume of 115 meters cubed. What is the volume in inches cubed? So this time we're starting out with 115 meters cubed, and we want to convert it into inches cubed. Okay, so I don't immediately know of a conversion from meters cubed to inches cubed. I don't even really know of a conversion between meters and inches, but I do know a conversion between centimeters and inches. And so maybe if I cube that, then I will have a conversion between centimeters cubed and inches cubed. And I do know a conversion between meters and centimeters, which I can cube as well, and that will help me solve the problem. So let's go ahead and write all that stuff out. So looks like the basic approach here is we're going to convert meters to centimeters cubed, and then centimeters cubed to inches cubed. Okay, so how do we convert meters cubed to centimeters cubed? Well, you will recall that 1 centimeter is equal to 1 times 10 to the negative 2 meters. And so I want to convert this into a cubed relationship. So I cube both sides of this. So I have 1 centimeters cubed is equal to 1 times 10 to the negative 2 cubed is 1 times 10 to the negative 6 meters cubed. So that is one conversion we can use. I'll just erase this for clarity. Okay, now centimeters cubed to inches cubed. So again, I don't immediately know of conversion to do that, but I do know conversion between centimeters and inches. I recall that 1 inch is equal to 2.54 centimeters. And so I'm just going to cube both sides like this. So 1 inch cubed, I'm going to have to use my calculator to get 2.5 for cubed. So it's 2.54, and I get 16.38764. We want to keep all these numbers because remember we were talking about problem solving before. So in intermediate calculation, you want to keep all the numbers. So this will be cm cubed. So I'm just going to erase this here. Okay, so let's go ahead and solve the problem at this point. So what I want to do is get the 150 meters cubed into centimeters cubed. So it's going to be times 1 centimeter cubed over 1 times 10 to the negative 6 meters cubed. So meters cubed cancel. We get an answer in centimeters cubed. Okay, so let's get this into inches cubed. So it's times 1 inch cubed over 16.38764 centimeters cubed. So centimeters cubed cancels out, leaving an answer in inches cubed. So let's see what the number might be. It's going to be on 115 times 1 times 1, divide by 1 times 10 to the negative 6. Divide by 16.38764. So let's see what number we get that. So 115 divided by 1 exponent 6, negative divided by 16.38764. Okay, so I get this long number on the calculator, which I'm going to have to round to correct number of significant figures. So I get 701,730.571. Okay, so we have 3 significant figures here. Both of these are exact numbers. We have 2 significant figures here. You may recall that when we have 1 inch is equal to 2.54 centimeters, 2.54 centimeters is an exact number, so it should be an infinite number of significant figures. When you cube that to get this number, 16.387 blah, 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 you should assume that your cubing an exact number will also create an exact number. So all these are exact numbers here. They'll have infinite number of significant figures. So the answer is going to be limited to 3 significant figures, which you had at the beginning of the problem. So we need to convert this number to 3 significant figures. So let's see, 1. So it's going to be 7.02. 1, 2, 3, 4, 5, 6 times 10 to the 6 inches cubed should be your answer. Okay, moving on. So now with problem 13, what the problem is, if the walls of a room are 955 feet squared in area and a gallon of paint covers 15 yards squared, how many quarts of paint are needed for the room? Okay, so this is another problem where we have sort of 2 pieces of information, and we have to see maybe if one of those pieces of information is a conversion that we can use. So we have 955 feet squared. And then, so do we have a conversion in there? And it looks like I think we do. It says, and a gallon of paint covers 15 yards squared. So it looks like 1 gallon of paint will cover 15 yards squared. So it looks like we're going to use this as a conversion in the problem, and then maybe eventually convert 955 feet squared using eventually this conversion. And I guess what we need to do is to get an answer in quarts. Okay, So how are we going to go about doing this? Okay, so what we'll probably have to do is convert first feet squared to yards squared. Now I don't immediately know that conversion, but I do know that 3 feet are in a yard, and maybe I can square that, and then that will be a useful conversion. And then once I'm in yards squared, I can use this conversion here between a gallon and 15 yards squared to get that into gallons, and then I can get gallons into quarts. So the first thing I want to do is convert 955 feet squared into yards squared. So to do that, I remind myself that there are 3 feet in 1 yard, and so obviously we can't use this conversion here, so what we'll have to do is square both sides. And now I see that 9 feet squared is equal to 1 yard squared. So it looks like I can go ahead and use that conversion to take that area in feet squared and convert it to yards squared. So it's times 1 yard squared over 9 feet squared. So feet squares cancel, we have an answer in yards squared. Okay, the next step is we want to take this unit of area and using the conversion that was in the problem, convert that into a volume, in this case gallons of paint. So I'm going to times 1 gallon over 15 yards squared. So you can see the yard squares cancel, and now we converted area into volume in gallons. But unfortunately, this is not the final volume we need. We need a volume in quarts. And so here, I remember that there are 4 quarts in 1 gallon. So gallons cancel, I should get an answer in quarts. So the problem is 955 times 4 divided by 9 divided by 15. So let's see what number I get here. So 955 times 4 divided by 9 divided by 15. And so the number I get is 28.29629 on my calculator. And so let's see, let's convert that to the correct number of significant figures. We have 3 significant figures here. 9 feet squared is equal to 1 yard squared. These should be exact numbers with an infinite number of significant figures. Okay, 1 gallon and 15 yards squared. Let's just assume that these are estimated. And so if they're estimated, then the 15 yards squared should have 2 significant figures. 4 quarts and 1 gallon, these should be exact numbers, and so should have an infinite number of significant figures. And so what I should be able to do is take an answer that will have as few significant figures as the number with the least number of significant figures. So we have 3 significant figures here, 2 significant figures here. This number needs to be rounded to 2 significant figures, and so the answer should be 28 quarts. Okay, let's move on. Glycerol is a liquid used in soap. So what is the density in grams per cm cubed of a 3.25 times 10 to the negative 3 liter sample that weighs 0.00903 pounds? Okay, so this is a density problem, and this is a little bit more complicated than the density problems you did previously. So let's go ahead and see how we might set up this problem here. So I suggest if you have a density problem, maybe the first thing you want to do is write out the formula. D is equal to mass over volume, and then try to assign variables. And so we have D here, M, and V. And let's see what variables we have. And so we're trying to find density, so that is unknown. The volume is apparently 3.25 times 10 to the negative 3 liters, so its volume is 3.25 times 10 to the negative 3 liters. The mass here is 0.009039 pounds. Okay, so here's the problem. We have a volume in liters, we have a mass in pounds, but we need an answer for density not in those units. We need it in grams per centimeters cubed. So what we'll have to do is we're going to have to convert pounds to grams for the mass, and we're going to have to convert liters to milliliters, and then remembering that 1 milliliter is equal to 1 cm cubed, convert that to centimeters cubed. So let's go ahead and do that now. So if we have 0.009039 pounds, so the conversion between pounds and grams is 453.6 grams over 1 pound. So let's go ahead and do the math there. So it's 0.009039 times 453.6. And so the number we get on the calculator is 4.10000904. Okay, so we have to convert volume in this problem, which is in liters, into centimeters cubed. So here I want to convert to milliliters, so it's times 1 milliliter over 1 times 10 to the negative 3 liters. And so the liters cancel out. We have an answer in milliliters. And then we remember that for every milliliter, you have a centimeters cubed. So it's times 1 centimeters cubed over 1 milliliter. So the milliliters cancel, we get an answer in centimeters cubed, so it's going to be 3.25 exponent 3 divided by 1 exponent 3. So I get an answer of 3.25. Let me throw in some units. cm cubed, and this is going to be in grams. Okay, so I divide this number in grams, divide by the number in cm cubed. Let's see what number I get. So I get 4.100094 divided by 3.25. And I get a number on the calculator, 1.26156, etc. So how many significant figures do we round this answer to? So it looks like all the manipulations we've been doing so far have been multiplications and divisions. Therefore, we want to use that rule for multiplication and division, where the answer should be rounded to as many significant figures as the number with the least number of significant figures. So here in the mass, we originally had 4 significant figures. In the volume, we originally had 3 significant figures. And so we want to round this answer to 3 significant figures. So the answer should be 1.26 grams per centimeters cubed. Okay, let's do one more problem, and I'm going to switch pens. Okay, this is another density problem. So I'm going to go ahead and assign variables, and let's just see where we're at. So D is going to be 0.918 grams per centimeters cubed. We're trying to find volume, apparently. And then here we're given the mass, which is 10.0 pounds. Okay, so there are really a couple of ways you can solve the problem. So one way that will work, and which you're welcome to do, is you can throw it into the formula D equals mv. And then what you can do is you have to solve for v. So let me remind you how you would go about doing that. So we have to get v alone on one side of the equation. So right now v is in the denominator. So what I'm going to do is multiply both sides of this equation by v like this. And when I do that, v in the denominator here cancels out with v in the numerator. And so now I have v times d is equal to m. Okay, so we don't quite have volume by itself, and so we have to divide both sides of the equation by d, and so you have v now is equal to m over d. So what you could do to solve the problem is you could take the 10 pounds of mass and convert it to grams, and then divide it by the density, which is in grams per cm cubed, and you'll get an answer in centimeters cubed. And that is a perfectly legitimate way to do it. I'm going to do it a slightly different way. So I can solve this problem using dimensional analysis. So let me show you how that might be done. So here we are starting out maybe with 10 pounds of fat. And so again, we have 2 pieces of information in the problem. So the question is there one piece of information that can be thought of as an equality? And the answer is yes. So when you see a density of 0.918 grams per cm cubed, you can think of it this way. You can put 0.918 grams over 1 cm cubed, because again, if it's per cm cubed, just imagine there is a 1 there, so you can put over 1 centimeters cubed. And this is an equality. So we have 0.918 grams equals 1 centimeters cubed. And so if you wanted to, you could write out the other fraction, 1 centimeters cubed over 0.918 grams. So let's go ahead and see if we can solve the problem. We're going to try to get an answer in centimeters cubed. And we're starting out with pounds. So density here is not in pounds per centimeters cubed, it's in grams per centimeters cubed. So what we'll have to do is convert pounds to grams, and then we can use one of these conversions to get that into centimeters cubed. So it's going to be times 453.6 grams per pound. And then the density conversion that we're going to use will be, let's see, 1 centimeter cubed over 0.918 grams. Now let's see if the units cancel out. So we have pounds here cancels out, grams here cancel out, and so we should get an answer in centimeters cubed. And so let's see what we get. So we get 10 times 453.6 divided by 0.918. So the number I get is 4941.1764, et cetera, et cetera. So obviously you have to round this to the correct number of significant figures. So we have 3 significant figures here. We have 3 significant figures here because this is probably an estimate for the grams to pounds conversion. We should assume that in density 0.918 grams is estimated, so we have 3 significant figures here. So we really want to round this answer, it looks like, to 3 significant figures. 3 figures here, 4 here, 3 figures. We want to round this to 3 figures. So we want to round it to 4940. So the answer should be 4.94 times 10 to the 3 centimeters cubed. Okay, thank you for listening to that. We will talk to you later.